This is probably the most exciting point in a program from the standpoint of activating the factory. The stage of the program that we're dealing with is called confidence hardware, and that's when we take flight form hardware, run it through all the tooling, use that for subsequent testing and fit-ups. All of the tooling that is going in is upsized to scale for the SLS program. Some of the vertical tooling is in a building that is probably 15 stories tall. The largest section of the rocket is the fuel tank, the hydrogen tank. You have to stack that with the other sections of the rocket, inner tank, the engine section, the forward skirt, put all that together, and you've got a very large rocket. We're looking at completing the first flight vehicle at MAF in May of 2016, and we're on track for that.
SLM is selective laser melting. It's a method of turning powdered metal, finely grained powdered metal, into solid parts. The design is done straight from 3D CAD models, which is standard in the industry. You can use any kind of commercial software, and the machine takes that and cuts that into a bunch of slices and builds them slice by slice. What we have to do in order to trust the material is we have to do a lot of testing on the ground. Back in 2011, we built a duct using this process for the J2X, and we hot fired it. And what we saw was basically no deterioration of the material. We built the one part for 35 cents on the dollar. More complex parts, we think the cost savings approaches of order of magnitude. If this technology proves out like we think it will, the schedule savings and the cost savings is almost beyond imagination.
The work that we're doing here is to support the Orion test flight, which is EFT-1. The hardware that we're manufacturing here in this shop is the adapter for the Delta IV launch engine to the Orion test article. To complete the welded structure, you have 3 vertical or longitudinal welds that join the barrel panels into a cone. It moves from the vertical weld tool to the robotic weld tool for the circumferential welds. The circumferential welds are the welds that join the welded cone structure to the forward and aft ring flanges, and that pretty much provides your primary structure.
We within NASA are passionate about STEM.
SLS was at Tennessee Tech for Engineering Week. We sat on a panel and we did video talks with several different elementary, middle, and high school students.
Their Engineering Week, they have shared with us, usually draws about 70 people. And on a Friday night, one of our programs drew more than 400. The more that we can get people involved in those creative ways, the more successful we're going to be.
The outreach for inspiring the future is such an important goal of NASA's.
So we have to foster that inspiration and that dedication to learning that's necessary in order to keep NASA's dreams alive.
There's a lot of work going on the VAB getting ready for SLS and Orion coming in 17. In the VAB, we built a full-scale mock-up. The main thing we're looking for is the handling and access. What we're looking at is getting some of the ogive panels from the GTA, which is the ground test article. They work great to do the practicing just like we used to see them in the labs. We are working pretty heavy on the EFT-1 part, and we're only 18 months away. The whole program, it's NASA successful. It's not just ground systems or Orion or SLS. So even though they're going off of Delta IV, having this flight successful does help SLS and GSDO. It's going to give us a lot of experience.
We did a one-year design on the entire crawlerway from the VAB to Pad A and from the VAB to Pad B. Over the years, the top-level rock has been refurbed multiple times. The actual foundation, the lime rock, which is what we're doing now, hasn't been refurbished since it was installed. We are reinstalling lime rock and bringing it back to print and then we'll install some fresh river rock on top, and then hopefully be good for another 50 years. Currently, the contract is about 20% complete. We're looking for a total completion date in mid-2014. The crawler transporter, as it finishes its upgrades, it will exercise or stretch and go up and down the crawlerway.
We have almost 47 different projects that touch almost every system on the crawler. The driver's cabs, the brakes, the generators. We're increasing the generator capacity so we're able to provide more power to the mobile launcher, to the vehicle, to the spacecraft. Within the next 2 weeks, we're going to be able to take the belts off the crawler, remove the old assemblies, and start assembling the new components in place, followed by the gel cylinders, the hydraulic cylinders. What the gel cylinders do when you're carrying a load, they automatically keep the crawler completely stabilized so the vehicle does not see any movement, especially when you're going up the ramp. After we complete the modifications, we'll be able to carry over 18 million pounds.
18 months from launch is not very far away, really, in the grand scheme of things. You think about trying to get all the systems on board. The guys are going great guns at putting all the secondary structure in, which absolutely has to be done right before they start putting the systems in. But you think about still all the wiring that needs to be done and all the plumbing that needs to be done and welded. Back in November, we had an issue. We took the pressure vessel to proof. We had a crack generated in the primary structure. So it was sort of all hands on deck, if you will, to go figure out what happened and why and how to fix it. And so we went in and just basically the guys created some fittings to offload the cracked part of the structure, and then the technicians at the ONC went in and cut the cracks out, and they're in the process of putting that all together now. So it'll be retested in April. For the next few weeks, we'll take a little bit of a back seat to getting the crew module through its big structural test, and the structures guys will put focused attention onto the service module, getting it finished and built up, and then it goes through a structural test as well.
CPAS stands for the Capsule Parachute Assembly System. We are doing the development of the parachute system for Orion. The military have developed a technique called low velocity airdrops, and they set up the conditions for which then to start the sequence of the Orion parachute system. And so we work very hard to reduce the risk as much as we can, to understand as much as we can in order for when we do fly this crew, it's going to be a safe vehicle. So over the next 6 months, very happy that we will be delivering our parachutes to the Cape, to the ONC building to be installed in the EFT-1 vehicle.
The NBL, we're kind of working on everything post-splashdown. We're working with the folks out of KSC and out of Patrick Air Force Base, and with Navy divers out of San Diego, putting together training material on how to actually go recover EFT-1 out in the ocean. We're using Navy amphibious assault ships, and what they do is they can ballast down and lower the back end of the ship into the water, and we can hook the capsule up and just tow it into that well deck and set it down in a cradle. There's about 17 folks when we get a dive crew available. So what we'll do with them is we'll put 2 sets of 3 in small Zodiacs, and they'll do all the hands-on work on the vehicle. The cradle that we plan on using for recovery, it'll be finished within the next 30 days. We're delivering it out to Langley. And then in August, put that equipment in a well-decked ship and actually practice a recovery.
I think there was always a hope that I would be working on a vehicle that would carry humans farther outside of low Earth orbit, getting back into the roots of what NASA was built on, which is exploration.
What could be more exciting than building the next great outreach for the U.S. government and for mankind, actually?
You have to let people know that we're still here. Oh yes, shuttle did retire, but we are still making progress and we are still moving forward.
NASA's nowhere near slowing down. We're preparing for the future. It's a great time for us to have such a tangible artifact of the work and the hours we put in. So yeah, we're really looking forward to EFT-1. It's going to be good.